All user program objects are located in various organized memory areas of the CPU. Different variable areas are the basis for the communication between the program parts and the system. We will now follow the course of a user program from the programming device through the various CPU areas of the user memory model. The user program and the parameters of the Simatic automation system were generated offline on a programming device using the Simatic Step 7 software. In the operating mode stop, a download of the user program and the configuration parameters of the hardware into the load memory of the CPU is triggered. The load memory is designed as memory integrated into the CPU or as plug-in memory card. When using flash EPROMs and micro-memory cards, the entire user program stored within is secured against power failure. After the download, the CPU operating system interprets the configuration data and on starting up sets the parameters for the modules which are part of this CPU. In the transition between operating mode stop and run, the program code required for processing the program as well as the user data are copied from the load memory into the work memory. The work memory has been designed as fast and entirely CPU-integrated RAM memory. In run mode, the execution system ensures processing of the user program. During the runtime, the user program operates with operands and variables located within the system and work memory. The system memory contains the following sections: the process image, which is the interface to inputs and outputs of the module. At the beginning of each program cycle, the operating system automatically ensures that the complete image of all parameterized inputs and outputs is updated and their status filed in the so-called process image. Access from your user program is then usually performed via this consistent I/O image. Memory bits are a universal variable area which can be used globally within the entire user program. Timers and counters are managed by the operating system. They can be used for easily realizing wait or monitoring times and part load counts without additional hardware and with very little programming. Temporary variables which during program processing lead to dynamic intermediate storage are filed in the local data stack. The block stack and the interrupt stack are used for internal management of the call hierarchy. For diagnostics purposes, they are only accessible in stop mode. Additionally, the system memory contains buffers for communication jobs to other stations and system message buffers for all of the diagnostics events of this station. The classification of memory areas and access methods by the user program is independent of the selected programming language or the CPU type. This uniformity is the basis for easily reusing programs and libraries also across different CPU types.